This week's episodes were brought to you by the generous support of Yukofin. So what we're going to do is we're going to call base.generateMap. So first call the base version to make all the hexes we need. Get all the hexes there. Try that again. Hooray! All right. There you go. We've got an ocean world now. We're ready to take a really crazy over-budget sort of thing. I don't remember how... Did we... Oh, yeah, we still have the crazy big world. Let me shrink that down, just because it'll make like generating the world a lot faster if we shrink this bad boy down. How are we? How do you think those overlays in city skylines when creating roads were created? I don't know what... Do you mean like the new overlays where it shows you angles and stuff? I'm not sure. Is there a reason you never use Scriptable Object? Well, yeah. So Scriptable Objects is great if you want a way to sort of store and edit data but still interact with the Unity inspector to do it. I find that there's a very limited use case for that. Most applications of Scriptable Objects, so Scriptable Object is something very similar to a normal mono behavior component in Unity, except it's not attached to a game object, is generally the way it is. It has built-in serialization and stuff with Unity and different things like that, but most use cases that people come up with for Scriptable Objects, I tend to prefer to just do as pure C# classes because I tend to not need to interact with the contents of that via the inspector. Is really ultimately what it is. There are some cool things that you can do inside of Unity for that, but I haven't found really important, especially not important enough to necessarily cover in tutorial, because I think it's just a narrow use case. I think if you've got a relatively simple application, you're perfectly happy just using game objects. And if you've got a more complex application, you probably need to do your own implementation with a pure C# class and your own serialization that's more sophisticated. So that's mostly what it comes down to. They're not used very often, and so I don't know if there would be a lot of value to covering it. All right, so where are we? Right, so we got our little ocean world that's being generated down here. Groovy. Although everything is still flat, so that's fine. So let's talk about making a content, right? What does it mean to make a content? So we're going to assume make some kind of raised area. Add lumpiness, right? Berlin noise, maybe. Then set mesh to mountain, hill, flat, water based on height. Then maybe simulate like rainfall, moisture, and set plains, grasslands, forest, which I'll make it as a separate thing, based on that. So you get, something that feels kind of right. By simulate rain, this probably just per line it for now, just to add some noise. But then you get some like drier patches, wetter patches, that sort of thing. At depth and ocean, well, probably there will probably be that. So right away you can start to get a couple of senses, right? So you've got this. So questions that should arise at this point is, okay, we want to elevate some hexes. How do we access the hex that we want? How do we set a height? Because right now, we have no references to the hexes. We create them, like we instantiate this, and we create a game object, that's fine. But that's it. So I mean, we could go looking for the game objects. I suppose we could name the game objects. That's something we don't do right now. We could make sure after we spawn the object, we could say game object.name is equal to. We could do the same thing as a string format here, something like this. You know, hex like that, and then we could search. That's terrible. No, of course we're not going to do that. That would be awful. I think naming it so that in the hierarchy, it shows up with a name. I think that makes a lot of sense. But we're not looking things up that way. That's crazy. So clearly, we're going to need some sort of way to store all of our hexes. And I think a two-dimensional array makes a lot of sense. Now, a two-dimensional array, there's two different ways to do it. You could have an array that's just... So you could have an array of hexes that's just a single, right? Like this, and you do something like it's num rows multiplied by num columns in size, and then you can reference a particular position by saying I want to access hexes at position. So the column is going to be some column number, some call multiplied by multiplied by num rows. So if you're in the first column, so column 0 multiplied by num rows, so it's just going to be 0 plus some row, right? So if I want 0, 5, then that's fine. Then it's 0 multiplied by 30 is 0 plus 5, so it's going to be the fifth hex in the array. If you're going to be on the second or third column or something like that, you can go 3 times num rows, so it like goes 90 units down, and then plus 5, so the 95th thing. So you can use a single dimensional array to represent this. But this will only work if your array is actually square. Now, as it turns out, ours is actually square. But it doesn't have to be the case. The same thing happens if you use a two-dimensional array like this, which is darn handy to work with, just because you don't have to do that silly multiplication. I mean, it's not silly, but it's a little bit more intuitive to do it this way. So now you can access something like hexes. Again, so 3, 5. There you go. You can access that. That's perfectly fine. Again, this only works if it's... Well, I was saying square. It's not necessarily square, or, well, it's not square. It's rectangular, but where each row is the same length, right? But it doesn't have to be the case. You could end up with a map that is like a hexagon shape, right? Kind of more roundy kind of map. You could make a triangle map. You could do all kinds of different shapes. In those cases, you may want to store your data slightly differently. Of course, you can use collections in C# where you've actually got a list of lists of hexes. So you get a new one of those. Oops. Right? And then, so row 0 is hexes 0 is equal to a new list of hexes of a certain size, and you can set things this way. And that's good if they're like uneven sizes, or if they're gonna have change sizes, things like that. I don't think this applies to us. I just wanted to have a discussion about it. There's different ways of doing it. I guess another way you could do it is you could actually use a dictionary. It needs a key. The key could be something as simple as a string. Hexes is equal to new dictionary. So then you could have something like hexes, 0, 5 is equal to new hex. Right? And you could just look things up that way, or maybe you can develop a different way to hash your hexes uniquely. That's perfectly fine too. I don't think that's helpful, and especially not in our case. I don't think it would be. I don't think it's needed. I think the easiest way for us is just to work with a two-dimensional array like this, because our maps are going to be square, and that's perfectly okay. So I think what we're going to want is, I'm going to get a private array to hold our hexes. And I suppose Where are we going to want to instantiate it? Probably here. Hex is equal to a new array. Oops. Upsize, num rows, num columns. I think that's perfectly okay. So private means this can only be accessed within the base hex map, not even the child class. We could go protected, but I think private's going to be fine for this. But we're going to need a almost certainly public way get hex at int x int y. Why are you auto-completing in such a bizarre way? You're good? You're good. Yeah. So if for some reason hexes isn't instantiated yet, then we actually, you know what? Complain loudly. We're going to throw a new exception. We can just feed a string in here, right? Hexes array not yet instantiated. We're just going to bitch and crash the program. And just in case, we'll return over here. But we're going to say, whoa, like, no. I suppose we could just do a debug.log error. That's probably okay. You know what? That's a little bit more Unity-ish. We're going to log an error with the same message. Hexes array not yet instantiated. I don't know what you're trying to do, but you're trying to access this thing before it exists. Just freak out. Otherwise, we will simply return the hexes at the position x and y. Now, the advantage of having it, be private in this is the question is, what happens if we ask for a hex that's outside of the range? What if we ask for something with a negative x, or an x that's bigger than 30, or rather equal to or bigger than 30? Those would sort of be invalid positions. But our maps are cylindrical, really. So should they not wrap on the right-hand edge? So let's say, for example, we're looking for neighbors, right? We're on the rightmost hex. The hex with the row 29 is our rightmost hex. And then we want to go to the right. So 29 plus 1 is equal to 30. Technically, if we were to return 30 over here, that would be out of bounds. Because remember, our array will go from 0 to 29. Are we perfectly happy throwing in, oops, not a hard-coded number, throwing in modulus over here, so that if you ask for x negative 1, this will actually return 29. If we ask for x 30, that'll actually return 0, and so on and so forth. Are we happy about that? I think so. I think that's the behavior we want. Now, the question does apply a little bit to the y part, because we don't have a world that wraps vertically. Now, last episode, I talked about why it doesn't really make sense to wrap vertically, because that's not really how a globe works. But there was an interesting comment that pointed out that if you're talking about a donut-shaped world, then it actually makes perfect sense to wrap north to south. It's like, yeah, that's true. Now, what we don't have is any sort of option to represent this right now. But I think we should. We should probably have a switch. Now, in our individual hex here, our hexes are told whether they're allowed to wrap east, west, north, south. And we use that for our camera placement. But I think the map itself should maybe know. Yeah, donut world, torus world. Exactly. Because really what we want to do is we want to allow these bits to be wrapped. So let's say, now right now we don't share this, right? To do link up with the hex classes version of this. So right now I'm just going to have it in 2 places, which is super bad, but let's assume that's going to change later. Classes version of this. At some point we'll link the 2. So then what we're going to do over here is say something like if allow wrap east west, then we'll say x is equal to x modulo num rows. If allow wrap north south, y is equal to y modulo num columns. And then once again we can just return x, y over here. So now we'll have options. If you don't want a world that loops, wraps in either direction, or you want one that wraps in both directions, then you have options over here. Boom, 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 boom. So right now it's hard-coded based on the default that you assume in 99% of 4X style games that are supposed to represent the whole world. Okay, so now we have a way. Well, we don't quite have a way. We're not done yet. I forgot to. There we go. So after we generate the hex, we need to make sure that our hexes array at column row. No, wait. Column row. Yeah, here too. Num columns, because we go width or X direction first, then num rows. I always get that inverted when I'm talking about columns and rows, but there we go. So we've instantiated this hex. We're going to store it at its X and Y coordinate like that. So we've got this array. We've got some disarray. Huh? So that's only part of the equation, really. What we also want is we're going to need some way to remember which game object belongs to which hex. So I think what we're going to want is a private dictionary. It might not stay private, but we'll see. Which is simply going to be a map from a hex to a game object. Hex to game object map, like this. Because we want to be able to say, hey, I've got this hex. Now I need to refer to the actual game object for it so that I can, change the visual component. So that's okay. So hex to game object map. After the game object gets created, we're going to say, so hex h is equal to hex game object. Because we're going to have to be able to reference that. Good, good. I'm making a poll or some sorts where you can go to any of the edge hexes. Oh, from the North Pole to the other. Yeah, that doesn't tend to happen in 4X games. You could do it. It wouldn't be that hard, but a little weird. I don't know. I mean, probably what you'd want to do is in your map generation, rather than make a square map, you probably would want to have it like sort of squarish, but then afterwards for the poles, just have it like triangle up to a point. Same thing at the bottom. There are certain map projections that would look kind of similar to that. And just saying the words map projection gives me like these like PTSD flashbacks to doing Project Mighty Spud. So let's not go there anymore. That's not how you add things to the dictionary. This does work. Right? Like you're probably thinking, do this way. Which, yeah. I'm pretty sure you can just do the assignment though. Yeah, let me try. I'm pretty sure this is valid. You can't read if something hasn't been set yet, but I'm pretty sure you can set this way. Let's find out. Let's see if it crashes. Now, whether one is better form than the other, I don't know. Yeah, see, no errors. Everything is fine. Because you can do this. What you can't do is something like if blank, is equal to whatever, some other things. We'll say null, right? If you do this, and H doesn't exist in the dictionary at all, this throws an exception. You'd have to do something like, if this contains key H and, blah, or some damn thing, right? You just check this. But yeah, you can assign it this way. You can use the .add, but, no, this looks good. It's fine. Oh yeah, that's true. Like yeah, if this already was there, it would just overwrite whatever was in there before. In this particular case, it doesn't really matter much, I don't think. I think it's fine. I don't know. I'm going to do it this way, arbitrarily. So anyway, now we have this reference, and that's cool. What I think we're also probably going to want to do is the section where we set the material and the mesh. I think it's going to need some sort of like... It's going to need some sort of like update function over here. Because we're going to have to call it for various things. Let's get there when we get there. Okay, so now we have a way, right? How do we access the hexes we want? We've got that taken care of. How do we set a height? So the easiest way to do it is in our hex data, we could add a little value in here for height. And I think that's exactly what we're going to do. Also, I'm going to move my head. My bad. I think that's exactly what we're going to do. I had thought about it, and I said, well, like, we don't really need the height info to be stored in the hexes permanently for the gameplay, right? If you think about Civ, like, you don't ever need to know the height of a tile. The type, sure, like hills and mountains, but that's not actually linked to height in any way whatsoever during gameplay. It's just like, it's just a tile feature, right? That it is a hill or it is a mountain. So I thought you could have, during your generation phase, you could just, like, actually in here in the continents thing here, we could create temporarily a float, like, two-dimensional array to store the heights, and just only keep it for a little while. And there might be some other things, like, oh, we'll probably need one for moisture and different things like that. But I thought at the same time, maybe it would be cool in-game to, like, mouse over a tile and find out, like, oh, this mountain is 1,100 meters tall, just for whatever. So we could just throw it in here, too. It doesn't... Exactly, it's not necessary. I don't know. You know what? It's probably a lot better, actually, if we just, you know, have an array to keep track of our heights over here. Maybe it's cool to have the data in-game as just like a flavor text thing. Because in Alpha Centauri, I think there were numeric heights for all the tiles. But on the other hand, the tiles really did slope quite high. And the height was important for, like, solar panels, I want to say. Regular invariable call elevation. Well, I'm going to make it a float in this case. Because... And I think calling it elevation makes a lot of sense. And the reason I'm going to make it a float is because most likely the values are just going to go from something like +1 to -1. Whereas like 0 is sea level or something like that. And then we can set ranges. We can say, if the height is from 0.5 to 0.75, make it a hill. If it's above 0.75, make it a mountain. And then you can tune those values. And we'll do the same sort of thing for the sort of moisture, terrain moisture. Which again makes me think of Alpha Centauri, because Alpha Centauri had a moisture value, which is really important for like optimizing whether you're putting a farm here or whatever. So we're gonna say num columns, num rows over here, something like that. Floating elevation, is that like a man-made island? Hey ho. Keep it in so you can make a working weather model. That's true. We could do like cool cloud effects on like the western or eastern side of the mountain, depending on how your winds are supposed to flow, right? Because let's say the wind flows from like west to east, you tend to get cloud formation on the eastern side of the mountains. Like the wind blows the humid air up the mountain, and when it gets high enough, it forms clouds. You get those like lenticular clouds right on top of the mountains. I mean, you could do that for, like, super highly realistic stuff. All right, you know what? F it. F it! Done. We're going to do that. I mean, maybe there should be a hex subclass for this particular project because it's a specialty thing, but I'm going to go ahead and make a... For now, we could have properties, we could have all kinds of different things. For now, I'm just going to have a public float elevation. Public float moisture. Done. We can encapsulate things, we can do different things if it needs sort of babysitting, but right now it's just like extra data. Data for map generation and maybe in-game effects. I will say that you don't necessarily need it here. You could keep it around. I guess you could still have it be a an array like this, but keep it here, and then you could reference it here. If you don't want to add data to your hex class, you could go ahead and do that. But what the hell? Let's throw it in there. It's going to be crazy. Crazy! So how does our raised area work? Procedurally generated tallest mountain in the world for tourism. Float also makes sense if you want a certain predefined amount. Yeah, well, that's the thing. Like, I think we'll have tunable, all kinds of tunable things, right? So if you have like a drier map, then yeah. Or one of the values in even in Civ when you do map generation is like sea level height, right? Low, medium, high. And I think what it probably just does is set the threshold for when a tile goes from being flat to being water. And you can just drop that down so you end up with more flat tiles and less water tiles, and vice versa. And then you can tune the hilliness and everything just by changing the range at which different tile types appear, which is going to be kind of cool. So yeah, float's way better for this than, I mean, you could do it with an integer or just a byte, and then you're looking from 0 to 255, and your 128 is your midpoint, and then blah blah blah. But you may as well just use a float because who cares? So I mean, we could do all sorts of like erosion type calculations and things. I think for this baseline continent map, I don't think that's going to be required. I think what we're going to do is just sort of like pick a point, blob out from it, and then that'll be good enough. On elevation change, on moisture change, would you fund actions for terraforming? Yeah. Yes, this will be on YouTube later on. So, and yeah, we'll per-line noise it, but what I want to do is I want to first raise one area. So then the question becomes, how do we want to do that? What should it look like? Let's go over here. Let's generate a map and take a look at things. And see how we feel. So, what if we just sort of like started somewhere and made a circle, or like a rough circle? How would you do like a rough sort of arbitrarily shaped blobby type thing? All right, if we want the continent to be, kind of like this, but again, more oddly shaped. A little less stuff over here. I can't just deselect and things. What would be our best approach? What we could do is in an area, we could do a few like area effects. Like imagine we're like, not fireballing, we're earthballing this area, right? We're dropping some earth balls. In a few different places, semi-randomly, but within certain confines. And in those areas, it raises up a certain amount of ground. And then that sets our elevation to be kind of interesting. I mean, we could just start off by making a rectangle. Honestly, just a rectangle combined with per-line noise might be perfectly suitable. We'll see. Use a roguelike room generation, but rooms equal continents. That's definitely a possibility. That was quite a lot of fun. Now, one of the tricky bits here is remember that drawing something that looks square isn't quite as intuitive as you might think, because if we just use like an XY loop, or again, we'll end up with something that's kind of a rhombus shape. God fired a meteor to generate some continents. Well, let's start by generating the code for making a round. Okay, we're going to start with that. Code for generating a round. And then maybe we'll do multiple roundy things. Probably it's going to be a, like, kind of a hex of a different size, right? Like a certain area. Starting from a middle point and going out 3 tiles in each direction. Let's start with that and then see what we can do with it. So let's make a little helper function in here called elevate area. It's going to want a X, actually, again, a Q for our column, and an R for our row as our starting point, and another thing for radius. So we want to say, and just for the sake of whatever, I'm going to say, we're going to start at 2115. So elevate area 21, 15 with a radius of 4. That's fine, right? So now we get to some cool cubic stuff. Because this would be very annoying in your traditional sort of like offset grid where every other row you got to like move things by a certain amount and figure things out and do some math. Here it's going to be kind of simple. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakefiend, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so much.